Today's guest, Max Woolf, has a pretty incredible resume of open source projects as well as writing that he's done. I found Max to be very interesting to talk to just because the way that he's gotten into data science is quite different from the story that I usually hear these days, and I do repeat that many times throughout the episode. I have been really excited for this conversation just because I think that Max has spent a lot of time thinking about and exploring many of the exciting models that we tend to use today for content generation and has himself built up some of these tools. To give his actual introduction, Max is a data scientist at BuzzFeed, and in addition to that work, some of the AI content generation tools he's created include aitextgen and GPT-2 Simple. This was a really fun conversation and got to hear a lot about the various projects that Max has worked on, his time at BuzzFeed, and his thoughts on being a data scientist. I hope you enjoy the episode. Max, you're now a data scientist at BuzzFeed, and possibly a lot of our listeners might have seen some of the work you've done on AI for content generation and various fun quizzes. I want to start with how you first got into AI and how you decided to work in data science.
Sure, that's a good question. I'll start at the beginning. Technically, I'm in college. I was a business major, but a statistics minor. At college, I learned a lot about how to use R. For those who may be more familiar with Python, R is another language most notably known for statistics and has been very popular in data science as of recently. My first job out of college was a QA engineer at Apple. And I had the consistent fear that I was going to get fired. So as a bit of a career hedge, I decided to go look into statistics and data science to see if I could see if I ever got fired, I'd have a plan B. Statistics, the big thing was you had a lot of self-projects. One of the things I did was I learned Python. I wasn't taught Python. I learned Python so I could scrape data from public sources, most notably Twitter. Back then, Twitter actually had a free and open API. That no longer is the case, regrettably. One of the first data science projects I ever did was noticing trends that I thought were unusual. The first one was with Medium. Medium.com, the blogging platform, was on the rise about 2012, 2013. Hacker News had a lot of submissions, a lot of meaningless thought pieces. And I was curious, how popular are these thought pieces? So Hacker News back then actually still does have a hidden API that you can use to scrape all the data. So I wrote a scraper. I got all the Medium data and decided to aggregate how many Medium posts are being sent to Hacker News and how well do they perform. And it's my first experience with ggplot. To give an explanation, ggplot is an R plotting library. It's probably one of the most famous plotting libraries, even a decade later. With it, you can create nice looking data visualizations very quickly and theme it very easily. I posted Hacker News. That went pretty well, and then after that, I decided to expand my horizons, just find more APIs to scrape. My most successful ones were Facebook. Back then, Facebook had an open endpoint that you can use to get data from public pages and groups. They've since closed them, unfortunately. Another one was the Reddit data. Fortunately, Reddit's API is still relatively open. Surprisingly, I don't think that'll last given that they went IPO. But I was able to do some analysis. That was also my first experience with big data. Reddit data is vivid. So that was my introduction to BigQuery. BigQuery is a data warehousing platform owned by Google. With that, you can just use SQL to gather large amounts of data. Reddit data was stored in BigQuery by a Google developer relations person. So I was able to just do some queries and just find everything. And it was open up a whole new world of what you can do with big data and data science. And I continued to do that, find things to scrape. Now getting to AI. In order to find new trends, I keep an eye on Hacker News to see what's popular. And the thing, one popular thing was a technique called style transfer. Neural style transfer is a method to transfer style of one image to another. The famous example being Van Gogh's Starry Night. You put that style in any image, but it was in a GitHub repo. So I looked at it and wow, this is really cool, but I could not understand the code at all. But it looked really cool, and I was able to run it on my system. And that also taught me how to use Docker, which is a data science skill that more people should know. And I'm surprised people don't talk about containers and how optimal they are. But I was able to run them. I was like, wow, this is so cool. I wish you could do more of this. And then I guess years later, in terms of like text content generation, there was a Twitter account called Robo Rosewater, which was for Magic the Gathering, the collectible card game. It used AI to generate text for cards using recurrent neural networks. And then this was before like the common like LSTM approaches that became more popular. I followed that. That was like opened my eyes to like the promise of content generation. Eventually, I figured out Keras, another post of Keras, which was TensorFlow based independent package at the time. Now it's in native to TensorFlow as a high level library. And it had examples, and it was very easy to read, just very easy to like reverse engineer, then create my own like models without that too much effort. And it helped like open my eyes to a lot of AI. Eventually, I became confident enough in my data science skills and working with Keras that I was not at that time. I was about maybe 4 to 5 years working at Apple. My skills weren't growing technically, so I decided to I think it was time to move on. And I left Apple, tried to get a data science job, and eventually I did. And at BuzzFeed, which is where I am now, and I've been there for about 5 years, and I'm enjoying every second of it.
That's awesome. Yeah, I feel like your journey into data science is really interesting because at least the way that I hear about people getting into AI these days, what you did sort of seems flipped on its head in the sense that, at least for me and a lot of people I know, the way they get into AI tends to be, oh, look at all these exciting models that are being put out there every day. And I think people get excited about, the cool math that goes on in there, and let me tinker around with PyTorch or Keras and get, these things working of, oh, cool, I can create this, image recognition model. And only later do people start having this realization of like these data and software engineering components and things like Docker are actually really important for this too. When previously at the beginning, it's just like, oh, let me play around with all these cool things in like a Jupyter notebook. And what I'd love to know is how the way you got into data science, since it really seems that it started more from the let me figure out how to scrape and work with data perspective. I'd love to know how that influences and informs the way that you do data science today.
Sure. Well, of course, a big thing about data science is ETL, just knowing how to process data, knowing how to visualize it, being able to describe it. A lot of reasons why I did like a lot of those blog posts is half informative, half teaching myself of how to like do things with data, especially since a lot of the techniques I did are not documented at all. There's no Stack Overflow. There's no thought pieces on like some of the more advanced data science things. And with R especially, there's less resources with R and some of the ETL there than Python nowadays. Well, nowadays I split my time 50-50 each. For R, I just still use for tabular data, and for ggplot, there's no Python comparison ggplot, despite many attempts. But Python, I spend more time, especially since AI, PyTorch, TensorFlow. You can do it in R, I just would not recommend it.
Yeah, that these days, I know most folks kind of just go at it with Python. I did have a little bit of an introduction to R myself back in college and have made very little use of it since then. But I do agree with you that the plotting utilities there definitely far outclass Python's. But I guess when you're only trying to plot simple things like, loss and accuracy and that sort of thing, maybe you're not too worried about the types of visualizations that you might think
That's
about.
True.
So I'd love to hear a little bit more about what you've been up to at BuzzFeed since you started there as a data scientist.
Sure. I've done actually quite a lot of different things at BuzzFeed. One of the first things I did working at BuzzFeed was social media analysis, which actually coincidentally pairs well to like this like analysis of Facebook and Twitter I've done like while learning data science. So now I can do that professionally and actually get paid for it. So that's nice. So that was the first thing I did. I created a few dashboards. I created some very fancy visualizations of data viz of like some of social media performance. I mentioned ggplot. I found you can put like millions of data points in ggplot and it can do that. One thing cool with ggplot is you can like facet. You can do facet like many different things. So sometimes I like facet like social media post performance by like say page. Just put it on one chart. Give them all different colors. It looks very pretty, although maybe not useful, but ideally pretty and useful. Another like major thing, I guess, more on the AI side was building recommendations. One type of content with all like social all like publications is evergreen content. Evergreen content is content that is applicable towards that can post at any time. Hacker News actually encourages evergreen content with special rules for that as well. One of the things I did was I built like a Keras model just to consolidate like metadata from BuzzFeed posts and create a model just to be able to identify like, is this post evergreen? And if so, can you like surface it? BuzzFeed also has an internal tool called PubHub. We've written about it on Tech Blog. BuzzFeed Tech Blog, tech.buzzfeed.com. We talked like some technical advances. We have a PubHub which helps social curators like schedule and plan content to be posted to social media. So one of my initial things working at BuzzFeed is to help like analyze performance of scheduled content to see if there's a way to optimize, like is there a way to improve sharing. And another thing is to use like evergreen recommendations. So we have like UI, so social, like here's evergreen content. This evergreen content might work well for this particular like Facebook page or at this particular time, which saves a lot of time for curators and also helps improve like aggregate performance as a whole.
Yeah, that's an interesting set of things. And I know that in general, BuzzFeed tends to be at least somewhat data driven, right, about the way it produces content and knows that along the lines of the work you've done, this sort of content performs well in these domains. And one thing I'd love to dig into a little bit, to the extent that you can share, is just as a data scientist, you can scrape all this information about how certain content is performing on particular platforms at particular times and all of that. And in the work you've done, how do you feel about the best way to make this kind of information useful and actionable for decision makers when you're trying to decide what content to put out?
You're getting to my second topic, which is building dashboards. Dashboards are always a funny thing because all tutorials on it's all proprietary software. Like there's very few good open source, despite many attempts. Like every open source, like say Shiny or Plotly Dash, has a lot of caveats. So there's a lot of enterprise only software that is for like when I was interviewing for data science positions, there was one job that was like, oh, we want you to build like a completely comprehensive dashboard. And then I looked like, I don't know if that's even possible in like the given open source software. And then I looked up and it turns out they were using a proprietary software called Looker, which is a popular BI tool. And when I brought that up to the interviewers, they were not happy about that you couldn't do open source, but you have to use a BI tool. I didn't think that was particularly fair, but it's a popular, like one thing I want to do open source is to create like my own dashboard software. That's like one of my projects I have marked up is for like a new generation of open source, actually free dashboarding software that's high performant. But getting back to Looker, BuzzFeed does use Looker to build dashboards. One thing you can do is you build it with tiles. There's some overlap with software like Mode Analytics. That's also popular, which like mixes notebooks and dashboards. You build dashboards. Looker offers like connection with the data warehouse. BuzzFeed's a BigQuery company, which works well with my BigQuery background. So it connects to the BigQuery data store. It has its own Looker markup, so you can like relate data and just be able to clearly like. But the big thing about Looker is that it can be easily used by non-technical people to build their own dashboards. So although other data scientists at BuzzFeed can optimize dashboards, there's a lot of flexibility for users to be able to like customize themselves and like add like features or filters in order to get the data they want, and also with the correct data visualizations and also alerting too. Like we can have like you can set like Looker just like send an email to or email report with data viz and or its tables of relevant metrics. It's good productivity software.
Yeah. So I guess what I'm taking away from that is, as a data scientist, you have a particular background. And so, you can maybe make sense of a lot of the data you see as it comes in different forms and tables, charts, whatever. And so from taking that raw data to the point where somebody on the other end is going to use and look at this in order to get feedback on how decisions they've already made went and how to make future decisions, these dashboards are a really great way just because the easy visualization provides them the exact sort of feedback that they need in order to look at various features of the data or get a sense of what went on where and really get to the heart of what it is they're looking for. I imagine that in the development of these dashboards, it's probably I can imagine it's a bit of a back and forth, right? Because you've got sort of this internal customer, maybe somebody who is using the dashboard in order to make decisions. And so there's probably got to be some back and forth of how do I design this to meet the specific needs of this person who's making decisions using it.
Exactly. I do spend a lot of time working with the stakeholders on like the dashboards, and I go to attend meetings as well. For example, like the dashboards I do to analyze social post performance. I talk to social curators who are the ones posting to BuzzFeed content social media. I talk with them, show them dashboards. Like if they ping me to add a feature, I add the feature, and it's worked out pretty well.
Yeah. So this process of, I guess, being a data scientist, there's a lot of various things that go into the job that you've pointed out. So there's understanding the data. There's a very small part, as you've pointed out in some posts, of actually doing modeling and all the cool AI stuff for people first get into. And then there's this managing of business intelligence and then also looking at various stakeholders. And you wrote this great blog post a while back that was called Real World Data Science. And I think that you started with a lot of great insights there. I'd love for you maybe just to summarize, having spent so long, in this path yourself, what some of the main takeaways have been for you in your time as a data scientist. And, say you're speaking to somebody who is at the beginning of their career path in data science or thinking about it, what would you want them to know?
Sure. To give more context on that blog post, I posted that blog post about a year after I joined BuzzFeed, and I guess that then I was still a little bit of a newbie, maybe a little arrogant to presume I know all about data science a year in as my first data science job. Actually, I do think that blog post holds up. We'd be linking the blog post to description of the podcast. Sure. Sure.
Absolutely.
So that blog post, what happened there is there was a Medium post on Hacker News. It's just saying, here's how do you k nearest neighbors, and then I looked at sidebars, oh, he's all little data science things to be real data scientists. No, that's not. Even now, 5 years into data science, I spend a lot of my time is things that do not appear in blog posts at all. I think that data science has, especially since towardatascience.com has monopolized long tail SEO and all things data science. A lot of the techniques have been pretty old. You have a bag of words, TF-IDF. What's the difference between accuracy and ROC, AUC? There's a lot of tropes that are very important in data science, I'll admit, but there's a lot of new techniques that are, I think, as important, if not more, but no one ever blogs about them. But any blogs about them would be very boring. So there's a little bit of a selection bias. The new term nowadays is MLOps. With MLOps, it's about getting the infrastructure. It's about getting about how to flow data, how to manage data, how to warehouse data. Data engineering's had increasing amount of overlap with data science nowadays. And data science expect to know also how to engineer data, how to do the business aspects cost benefit analysis. Give a practical example. Of course, you're familiar with VQM plus clip. The big thing about any AI image generation is compute. It's very expensive. You need to figure out how to use GPUs. It's pretty much impossible without some tricks to be able to do a start VQM plus clip at reasonable quality and without having to spend a ton of money just trying to be able to maintain it, because it requires some very interesting DevOps techniques to get around that. To get around the massive amount of GPU compute. Some models you can use CPU compute, you can quantize them, you can you can freeze them to get them fast, but some other models you have to think about interesting engineering challenges to be able to do them correct at a cost-effective manner so that you actually don't lose money on them. About 2018, 2019, I did GPT-2. That was a new model, and that was bigger than all the models. That basically we're trying to figure out how to maintainably deploy GPT-2. Was my first foray into how to do efficient data engineering, and I had a lot of mixed success with that.
Yeah, can you tell me anything about some of the takeaways and challenges in the data engineering you did for trying out GPT-2?
Sure. GPT-2, to give context, when I first did GPT-2, there first was a Colab notebook. And I think Colab's probably one of the biggest boons to open source software in probably the last few years, when you think about
Indeed.
it. Right. But Colab, GPT-2, multiple models released initially. The small one is 124 million hyperparameters, which sounds like a lot, but nowadays it's kind of pathetic. Now we have GPT-3, which is 175 billion parameters. But so GPT-2 small. The issue with GPT-2 small is that it had difficulty fitting into memory reliably. Back then, it actually is kind of still nowadays. GPT Colab gives you a K80 NVIDIA GPU, which has 8 gigabytes of VRAM, and that could very barely fit GPT-2. But to fine tune it, but it was possible. You could do new techniques had to be invented to get like larger models, such as graded checkpointing, which are still used today for like the super giga ultra models. But one of the reasons I made GPT-2 simple was to be able to packagize like a trained, fine-tuned GPT model and be able to like deploy it in like a Docker container. Eventually, I settled on Google Cloud Run, which was new at that thing, which is similar to like say Amazon Lambda. Although you put in a container, Docker container that you can call the container to serve like requests. So I experimented with doing GPT-2 in like a Docker container. The big thing about Cloud One is scaling to 0. If you like talk about efficiency, if you leave it on 100% efficiency, that like all the cost benefit analysis assume 100% efficiency, which is never the case. But with things like scale to 0, which Cloud Run does, then you don't all have to do 100% efficiency, which makes deployment a lot sooner. So, and also Cloud Run lets you scale to infinity. So when one of my models went viral, it could scale up to that traffic without any issue. Although cost wise, it wasn't great, obviously, but I think for an easy deployment, we can deploy a lot of models and scale quickly without GPUs. That was an interesting thing, and that's why like DevOps, like there are several blog posts about how to like deploy models, but they are very optimistic and don't reflect like some of the realities and constraints of deployment. And even I guess even now with like BuzzFeed, the way deploying models to BuzzFeed is a little more complicated. I've spent like multiple months just trying to figure out how to do it efficiently as well, working with data engineers.
Yeah, there's definitely a lot of considerations that go on in doing this, I think, because there are so many different techniques that you can use. And with today's models, I guess this really depends on where you are and if you actually have any real use for them. Mm-hmm. But as you pointed out, once they get large enough, once the data gets large enough, you already have this problem of, I can't fit all the computation I want to do on a single GPU. So then you have to start worrying about the model parallel, the data parallel, and then all of this other stuff comes in of communication overhead. How do I balance things? How do I synchronize gradients? All of those really fun considerations that go in there. And then what you're speaking about too, I think these packaging questions, I feel like even a lot of people in ML who maybe are familiar with data and model parallel haven't thought about those quite as much of, how do you containerize things? How do you set up endpoints that you can ping? And how do you deploy these in such a way that people can easily do inference with all of that? And then how that interacts with the compute that's getting used every time you do inference. So there's, as you pointed out, just a lot of really interesting questions there. And the process of doing these models, I feel like to an extent, especially as we've gotten into the GPT era, because the modeling side has been a lot of just scaling up transformers, right? And so there's definitely innovation going on around transformers, and people are coming up with cool ways to, try to play with attention, make it more efficient as opposed to the n squared computation that goes on in general. But a lot of the advances we've seen are just from that scaling hypothesis. Take the big language model and make it even bigger. And so as you're pointing out here, a lot of the interesting stuff going on right now is on the software and data engineering side of how do we actually deploy these things and make them work in training and in inference.
I think the work on like making transformers smaller is more interesting. The big innovation I think in BERT in the past few years was Distilbert by the Hugging Face team. Distilbert is a variant of BERT, which was distilled, which gets about the same performance as the largest BERT, but much smaller. It's about 60 hyperparameters, and so you can actually reasonably deploy that. And think while deploying the big BERT is a major technical task.
Right. Yeah. You definitely don't want to deploy like a 300 billion parameter model and ask it to do inference that frequently. And I think some of that other work too, along with Chinchilla, for example, right? Scaling down the size of the model a little bit and then maybe just training it for more tokens has that benefit of even outperforming a 4 times as large model. And then you get that inference time benefit too.
Mm-hmm.
So I think there's definitely a lot of considerations just in terms of how do we extract the right performance out of these. And I think that distillation is one promising way. The other ways that we can sort of pursue scaling by maybe training for longer is another promising way. But I guess, the end goal here, right, is that eventually these models want to be deployed somewhere and used for inference. And so there's a very strong motive to pursue making them smaller and maintaining the kind of performance we're seeing out of these super large models.
Exactly. I think there's a lot of tricks. Like the big trick I saw with like ImageGen, which is what Google's new text training model they announced a couple days ago. They use a trick. The input is a frozen T5 model, which is a very large text. I think it was all types of content model, one of their Omni models, but they instead of like feeding images, they just froze the text from previously trained model, and they actually got a lot of mileage out of that. So I thought that was very interesting. I think the secret towards more efficient generation will be just high pre-training, especially on like image generation. There's a lot of good papers on very good quality on image and text.
Yeah, ImageGen is super interesting to me. I think just as you pointed out, how their text encoder, that frozen T5 model, you didn't have this thing that went on and in the pre-training portion of DALL-E 2, right? For example, where it was trained with that clip objective, and there's that explicit inclusion of images and the whole contrastive thing to try to coax the image and text embeddings to be similar to one another. So the way that ImageGen differed from that, I thought was super interesting. But now that you've brought that up and we're thinking a little bit about this AI for content generation stuff, I'd love to get a little bit onto some of your work about AI for content generation. First off, though, I'd love to ask about what made you interested in the idea of AI content generation in the first place, and what you think some of the benefits of having these tools is.
Sure. The truth about me getting interested in AI content generation was to create better shitposts. The very first experiment into text generation was Markov chains, of course, which is like the prototype of how you always do a text generation. It actually did it on scraping GitHub, top GitHub repository. So you had like create your own like type of GitHub projects just by using Markov chains. It had interesting results, and then eventually you get to actual much better with RNNs, get LSTMs and transformers. Things get much fun for there. But I'm interested more in content generation, more for fun. It's not for like make my life easier. But I think there's a lot of fun things that avoid like some of the have a human anchor bias. And like humans, we're just avoid certain like types of thoughts. But of course, AI is systemic bias, but anchor bias. I think AI with the temperature. If you do like temperature, just you deliberately choose things, choose like answers that are less optimal, and with that you can like mutate into more interesting ideas that a human may not otherwise have thought of.
Yeah, that's interesting. So what you're distinguishing there, if we can spend a second on that, are these two types of bias. So we've talked about, I guess, the type of bias people mostly think of these days is the second one you pointed out, the systematic bias that comes out of AI systems. And so this human anchor bias has to do with sort of the deliberate choice.
It's more on a creative aspect. Yes.
Yeah, that's definitely interesting. Can you elaborate, I guess, a little bit more on what that looks like?
I think a good example is like the AI art. If you've seen like a lot of AI art, a lot of them are very surreal. I think like things that more humans would not like think about or like ever illustrate. I think that's like a good example of like anchor, like avoiding the anchor bias. Like humans, like I know a lot, even like creative, like some of the very like it gets the DALL-E 2, like a lot of like grizzly bears, like very, if you've seen like the Twitter accounts, I've done like very cute things, like grizzly bears doing like calculus, grizzly bears at the stock market. There are artists that do do some surreal things, but I think there are opportunities there for like things that humans would not easily do, and then from that humans can feed back into it. I don't think there's a lot of discussion about like AI replacing artists. I don't think that's going to be the case. I think it's going to be collaborative. I think AI is more of a tool for like creative art. And I think there's a lot of potential that hasn't been realized yet. And I wish DALL-E 2 and ImageGen would be released and more publicly available, so that could be more realized.
Yeah, it was a little bit disappointing that those two weren't released publicly. And Imagen especially, I think, just looking at the insane realism of the outputs that it has would be really interesting to look at how that coheres with artists. At the very least, I guess, we've had these clip plus view QGON tools, so people can tinker with something that at least approximates what's going on in there. And so you can still do that image generation from whatever text you're going to input. So at the very least, there's some tools around there. But yeah, my hope is that some of these more advanced tools can be open source in the future, because it does seem like this idea of humans coming together with AI systems and this joint creation. There's a lot of interesting stuff going on there.
Definitely.
So going on a little bit to thoughts on some of these existing models, we can maybe step back a little bit. The moment recently, of course, that brought about a lot of what's going on with Clip and DALL-E and all of that was when GPT-3 came out, and people got really excited about it after somebody posted some code snippets it had generated.
Yeah.
And you made a blog post of your own where I think you said, when a cool looking magical thing gets the attention of VCs, discourse tends to spiral out of control, which I really liked. How do you feel about the discourse around GPT-3 and its child models today, now that we've had it around for a bit? And do you have any thoughts on just the effects of this sort of hype around models like GPT-3?
Fortunately, I think the hype around GPT-3 that specifically has cooled down a little bit. I've actually been using it more for like professional things. I use GPT-3 unironically, and I've had good results from it. I won't spoil them. It's always good to keep an eye on like how other models. Well, the big thing with GPT-3 is they added Instruct model, which actually performs very well. I'm very surprised by how well the Instruct model performs. That was released in January. Okay, back on topic. Back on top. GPT-3. It does still take. It's not perfect. GPT-3. Still, when I wrote that blog post, it was unreasonable amount of media frenzy. There was a lot of clickbait, and I strongly dislike I dislike misleading clickbait. Anyways, there's like people like, oh, this AI can do anything. Well, this it's similar like the AI generated art controversy. Will GPT-3 replace writers? 2 years later, that clearly isn't. That's clearly not what's going to happen. But there has been a lot of interesting writing tools. There's been a few startups that actually have been performing well based on GPT-3, but it is expensive though. So I do wonder about the cost economics of running GPT-3, but that's a topic for another day. From a creative aspect, I think GPT-3 is a very good idea generator, which is part of some cases I've used for myself to generate ideas. But it's not going to comment. It's not going to replace authors. It's not going to replace coders. I've used Codex. You can go GitHub Copilot. I've done some experience with that. I've gotten some fun outputs there as well. But I don't think that would replace like coders. It won't obsolete Stack Overflow.
Yeah. I think the consensus that really people came to was that, this is going to be a great augmentation tool, right? But in no way are software engineers, front-end engineers going to be replaced by it anytime soon. And I think, as you pointed out, a lot of just immediate media hype and frenzy over it that happens in the wake of, oh, we did this cool thing, is just going to occur and drive the discourse to just all these weird places. And then eventually people tease the model a little bit more, understand better how it actually performs. And then by this point, of course, the hype has really subsided a little bit. But it's always interesting to see after the first release of one of these models. Of course, whoever's releasing it, people talking about it initially are going to be like, look how amazing this thing is. And probably not when to spend as much time talking about the limitations. But it's pretty clear what they are. And I know that a lot of work on things like even, basic common sense reasoning, right? GPT-3 does not do super well on those types of tasks.
But the answers can be fun at some point. That's good. It's good shit posting.
They can be fun. Yeah. I really liked the prompt in the Instruct GPT paper. Why is it important to eat socks after meditating? And both Instruct GPT and GPT-3 had some really interesting takes on it, but neither of them were like, this is a dumb idea. That was pretty fun. So you note at the end of the article on GPT-3 and tempering expectations that somebody using the OpenAI API professionally should know a couple of things. And the final bullet there I thought was really interesting, and I want to spend some time digging into. And this was about AI generated content ownership and copyrights. This will be fun. And I guess as you're probably aware, this has been a point of contention recently. I know that there was something called the artificial inventor that created some work, and its inventor wanted the AI system to be on the copyright for that work. And initially, in the United States at least, they got rejected for this. Mm-hmm. So I guess having worked on some AI tools for content generation yourself, how do you approach that question of whether AI systems can be granted ownership of or copyright over work that they generate?
I'll start off saying I am not a lawyer, but especially for some AI generated content for BuzzFeed, I've been keeping an eye on the laws and the legalities of like some content, especially with like AI generated images, like how much, because that way it's at least very obvious to see if it's saying overfitting on like the input data. So if it's doing that, and the issue is there's no good legal precedent. I know you mentioned like AI. I know there's a little bit of a meme saying AI computer generated content can't be copyrighted, but that's not a legal precedent. There are concerns that haven't been legally tested, and I honestly hope they do get tested at some point, so I don't have to think about. So we have like something we can concretely refer to.
Yeah, I think that's probably the good TLDR take on it. There's just not much of a legal precedent, and I guess that's the case with most things about AI these days. There's a nice attempt to take existing law and then apply it and interpret it so as to speak about these AI systems. But really, if you're going to be very specific about how the laws were written, what was in mind when they were being written, it probably was not with these AI systems in the imagination of the people who were writing those laws. I guess another thing that I thought was interesting about this AI inventor piece was, and I think this maybe speaks to the need for revision of the laws themselves, but if I remember right, the defense that was being written took a pretty clear interpretive stance on the idea that this AI system was able to, independently of any human input, generate the content that they were trying to copyright with the AI system's name on there.
Independently is doing a lot of heavy lifting there.
Exactly. I thought that was doing a lot of the heavy work there, because I'm kind of doubtful that they could have developed an AI system that independently of any human input whatsoever, because that would have to mean not just independent of input at inference time, but independent of data that was fed into it during the training process.
And curation of data is augmented by human bias. So that
exactly
is a problem.
Exactly. Yeah. So I feel like if you try to interpret these questions according to existing laws and fit it into what's going on there, you run into a lot of trouble, because you're trying to squeeze out of these questions where it's pretty clear AI systems can't totally independently of human input create things on their own. That's definitely not the case right now. And so I think that this just calls for better understanding what we want the laws to be. Are there like trade-offs in allowing the systems to be on copyrights and things like that? So we've talked, I guess, a little bit about the various ideas just around AI for content generation. I'd love to talk a little bit about some of your fun projects and one-offs. I think that you referenced a couple of these a little bit earlier on, but let's actually start with this one. I thought was really fun. You trained an AI system to generate Pokémon designs at one point, and BuzzFeed released a quiz allowing users to create their own. Tell me a little bit about the system you used for that. If I remember right, you used Rue-Dolly fine-tuned on original images of all the Pokemon, right?
That's correct. I'm going to give an example to elaborate more on that. Rue-Dolly is a model released by Sberbank, a Russian-based financial service. They really Rue-Dolly is basically, it sort of uses the same technique that OpenAI used for their own Dolly. Just train on images, but given text, generate images using a variation autoencoder as a codebook as a decoder. Someone contributed a fine-tuning notebook to that repository, and I had a hunch. I knew big thing about these type of models, so you need normalized data sets, and I figured that Pokemon, I knew that was normalized data set. I knew there's a public API that lets you gather all the images. So I wrote a quick scraper, got a Pokemon data, and then I just fed it to the model. And as a rarity, from the first time I tried it, it actually worked out. It worked out perfectly. That never happens with AI content generation. That you get it right on the first try. So then I I generated a few. They were all good. I posted on Twitter. Posted tweeting and went viral to about over 10,000 retweets. Posted to the Pokemon subreddit, about I think 30,000 upvotes. So people really liked it. I generated a lot more. The good thing about this is on a Colab, is trained on a Colab GPU. The model itself is about, I think, 1.2 billion. It shows how much efficiency of fine tuning has gone over the years. I added a few features such as to generate in bulk. So one of the things I did, it traded like hundreds, thousands actually of Pokemon. Then I was able to do that and then just put it into a notebook. I was able to share it. But for BuzzFeed, I've done like a lot of we've done a lot of AI stunts, done AI projects. But this Pokemon was one of them since it went viral. So I generated like a lot of Pokemon. I also trained a separate Rudali model on only the first 151 Pokemon, which using the style that was back in the 1996 by the Pokemon principal artist. So that created a much different Pokemon style, which very manifested too. I also did a few more like one-offs of Pokemon. I trained Rudali only one Pokemon, just one Pikachu, and then it actually worked and created like Pikachu abominations. Trained on two Pokemon, and it actually did do hybrid Pokemon of those two, which are very discernible, and I was impressed by that. So this is more like one shot and two shot with similar logic with that.
Yeah, the one shot and two shot behavior of these systems is super surprising. So it's kind of cool that you were able to see that with Pokemon as an example. I was going to ask you about the difficulty of training this system, anything that surprised you, but it sounds like, as you said, you were able to just kind of do it in a Colab notebook and it worked the first time.
There was one interesting, is that has to deal with the learning rates. For those who know, learning rates often go on a schedule, and there's been a lot of new techniques on how to best schedule learning rate training. The notebook used something called one cycle learning rate, and I had to look up what the hell is one cycle learning rate. So I had to do like deep dive documentation, like tune up parameters, because if the learning rate's too high, it model overfits. I think actually it did overfit the first time, but that's obviously fixes to have a lower learning rate so the model doesn't memorize it or load the steps. One thing I did just tweak like the one cycle learning rate parameters in PyTorch, and that actually worked out pretty well. The overall sense of like all the learning rate schedules is like start out high, then go gradually lower, so that the model doesn't convert. Model doesn't escape a local converges and doesn't like go off to another local minimum.
Yeah, I guess that's kind of the main idea behind a lot of these fancy techniques. And it's interesting how people manage to find ways to make things more and more complicated just to squeeze out like every last bit of accuracy or performance out of these things.
It's a cheap way.
Actually understand. Yeah.
It's as opposed to like doing new GPUs. Like I know, like I think Atom, like I know people like, Atom or add Ada factors. Like a lot of it goes like which one takes more GPU memory. So there's a lot of like other constraints that are requires again all back to engineering things that aren't really discussed about blog posts.
Yeah, that's a good point. And I guess a lot of the things we've talked about today, especially on the software engineering side and how that relates to data science, you've pointed out, aren't really in blog posts. And it's interesting, but also makes a lot of sense how that just kind of continues today, because there's topics that people are going to be naturally attracted to. And so a lot of the ones that tend to come up, I guess, a lot in the actual career of a data scientist just aren't things that are super amenable to catchy blog posts. Mm-hmm. So I guess as a final thing on one-offs, you referenced this earlier, but you had a fun Twitter post in which you asked GPT-3 for ideas on data science and ML for a roundtable discussion. Mm-hmm. If I remember right, in particular, you asked it to brainstorm like silly ideas and topics that BuzzFeed data scientists had probably never talked about before. Mm-hmm. Did you end up discussing any of those topics? I'm curious how that went over.
I'm glad you asked. To give more context, that was me testing GPT Instruct. One of the things you can do with GPT-3 Instruct is to give like commands such as brainstorm is one of the easiest things. And the GPT, if you did that on the previous models of GPT-3, it would not work well. It'd probably go on a tangent. It'd probably go on a rant. Probably say something kind of offensive. But if you do brainstorm a list of ideas for BuzzFeed data scientists discuss, you would do that. So give more context. But at BuzzFeed, we every Wednesday we have like a little bit of a gathering thing. We talk about like a notebook, talk about like a book or research paper. We were starting to run out. We finished the book, so we run out of ideas. One thing I did, so hey, why don't we ask an AI for ideas? And so I put the GPT-3. It gave some ideas that were actually feasible, which is what I ended up posting on Twitter. And so after we did talk about there are ideas such as how to use data science to optimize your laundry, how to use data science to optimize your dating, how to use data scientists to save the world, or just like some other fun things like that. We just ended up discussing early, so then we decided, why don't we have the AI do discussion for us?
That's fun.
And then it actually did a better job than us, and I was very offended by AI superiority.
Maybe one day we'll just cancel all of our meetings and have some GPT-X talk to itself instead of spending 30 minutes of our time on a Zoom call. So I guess where I'd like to end, and we spent some time on this earlier, just as some closing thoughts. We've kind of already articulated your journey as a data scientist and how I think that tends to differ from the way people think about it nowadays. And I can see in, the way you approach problems and sort of think about doing new things, you come at it from, I think, maybe a different perspective from like a lot of young people today who are just starting to get into AI, thinking about all of the modeling aspects. And so if you could leave somebody who is maybe just at the start of their journey, we sort of already asked a version of this question, but if you could leave somebody with just one gem of advice as to how to really effectively become good at doing data science, what advice would you leave them with?
Keep an open mind. As I mentioned, like there's there's data science. There's a lot of new things coming out. There's no like one good, perfect solution for all problems. Like every problem has different ways to approach it. I'd encourage you to do unique things as well. Don't necessarily just use like do the Titanic data set in Kaggle, and then I'm a data scientist. There's like you can try and find your own data set. Which admittedly was a little bit harder because Twitter and Facebook closed down. They were very fun data sets. Data science, of course, rewards like creativity. If you're creative, and that's also one that's like AI. So AI can help creativity, which can help all improve data science. So it's all connected.
Yeah, that's a good way to put it. I think that data science is one of those professions where there's a huge impact on the way we do things, and there's just so many different functions that have to happen in one person and one job role, that it's almost a necessity of the job to, as you said, keep an open mind, be ready to learn new things, try out new techniques, and it's always evolving. Well, Max, thank you so much for spending the time chatting with us. If our listeners would like to learn more about you and the work you're doing, where would you point them?
You can point them to my blog, Minimaxir, MINIMAXIR.com. My Twitter my Twitter account is Minimaxir @Minimaxir. Also, before we close, I want to add that BuzzFeed is hiring senior data scientists and senior machine learning engineers.
Awesome. Well, with that job post, we can end for today. Thank you again, Max, for spending the time.
No problem. Glad to be here.
That's a wrap for this episode. Thank you so much for listening to this edition of the Gradient Podcast. You can find our podcasts, newsletter, and other articles from thegradient.pub and our Substack at thegradientpub.substack.com. If you liked the episode, please consider supporting us by sharing it with a friend or subscribing. And as always, we appreciate your ratings and feedback. See you in the next episode.